Algebra 2 class. The topic we'll be covering in this video series is exponential functions, growth, and decay. This is Chapter 4, Section 1 in your Algebra 2 textbook, and our primary objectives will be to write, graph, and evaluate exponential functions in order to model growth and decay. Now, the first question we want to answer is, what is an exponential function? Well, an exponential function is any function that takes on the form of f of x equals a times b to the x. Now, there are a number of things to point out about this kind of function. First, you may have noticed our input variable x is now located in the exponent of our function, hence the name exponential function. The next place to move on to is b. Now, b is the base of our exponential function. This is the thing that the exponent is attached to. It is a constant that's going to be repeatedly multiplied by. Now, there are some restrictions on what b is allowed to be. For example, b has to be a number that is greater than 0. It cannot be negative, and it also cannot equal exactly 1. Now, the reason it cannot equal exactly 1 is because if we raise 1 to any power, it's still just 1. So we wouldn't have an exponential function, we would actually just have a constant function. The last piece to talk about is a. Now, in most application problems, a is going to end up being our initial value. It is the first output that our function will have when x is 0. In other words, when we have not multiplied by b any number of times. Now, graphically, what you'll notice is that that means a is our y-intercept. Now, one thing I want to look at is what the graph of an exponential function actually looks like. So I filled in a table of values for us for the exponential function f of x equals 2 to the x. So I picked some easy x values to use, -2, -1, 0, 1, 2, and 3, and plugged those in for x in our function. Now, you may have noticed our graph takes on this smooth curve that seems to increase more and more rapidly as x increases. Again, this is because every time x increases by 1, y is actually being doubled. It's being multiplied by 2 repeatedly. Now, one possibly new vocab word for you is this idea of an asymptote. Now, if you notice the dotted green line on the bottom of your graph, that is an asymptote for this function. Well, an asymptote is a line that a graph approaches but never touches. So what that means in this case is that our graph is going to get really, really close to y equals 0, but our output will never actually be 0. Even when x gets really negative, y will get really, really small, but never actually reach 0 itself. The last thing I want to talk about is what makes something exponential growth and what makes something exponential decay. Now, in most application problems that we'll be interested in, we will have an initial starting value that is positive. In other words, a will be greater than 0. So in these cases, if b is greater than 1, in other words, if our base is greater than 1, then that will be an exponential growth function. So what that looks like is as x increases, our y value also increases. And remember, as x gets really negative, we approach y equals 0 but never touch it. For exponential decay cases, that will be when b is between 0 and 1. In other words, b is things like 0.3 or 1/2 or 0.96. Right? Those are all between 0 and 1. In these cases, our output will decrease as x increases. So it will look more like this. We will still have an asymptote, except in this case our asymptote will be as x gets really, really big instead of as x gets really, really negative.